This question gives us a nice little graph, tells us the function polynomial quartic, means fourth degree polynomial. Identify the interval on which it's concave up. So they want us to find where it's concave up. Remember how concavity works? It it looks like there's a point, I don't know, maybe right around here. I actually know the answers already, so I'm going to kind of cheat. That looks like it's changing concavity, right? It looks like this is a bowl turned down. It's concave down. Which means what? F double prime is negative. Remember the second derivative is concavity? And then a section right in here that looks like it's bowl turned up. That looks like concave up, which means F double prime positive. And then another section in here where it goes back to concave down, which means again F double prime is negative again. So, right, so you can kind of see it, right? Bowl turned down, bowl turned up, bowl turned down. Now, how do I know exactly where they connect? Well, because I already know the answers. They're right there. But I'll show you how we get them. Anyway, you know it's somewhere in that vicinity, that vicinity. You can tell. I was like bowl turned down, suddenly it changes to bowl up. Now, those specific points, right, there and there where it changes, their F double prime is zero, and they're called inflection points, because that's where the concavity changes, meaning it goes from bowl down to bowl up and then to bowl down. So where you change, right? Because the F double prime is negative and then zero and then positive and then zero and then back to negative. So at those places where the second derivative is zero, those are inflection points. I got to find those. That's the 2 points because that'll tell me where it's concave up, which is what they're asking for. Where is it concave up? So I got to find where the second derivative is zero. Those are called the inflection points. So how do I do it? Well, got to take the original function they gave me. I'm going to rewrite it because I hate fractions, as you probably know. So this is minus a half x to the fourth minus x cubed plus 6x squared. Just make it like that. You might say, well, you still got a fraction. Yeah, but I don't have x involved. So I don't want fractions where x is in the top or the bottom. Now x is just out front. It's not part of the fraction. That'll make life so much easier when it comes to doing derivatives. So here we go. Let's do our first derivative, f prime. So the 4 comes down. Half of 4 is 2. Subtract 1 from the power. Bring the 3 down. Subtract 1 from the power. Bring the 2 down. Subtract 1 from the power. There we go. There's the first derivative. Now we need a second. Second derivative. Bring the 3 down. Minus 6x squared. Subtract 1 from the power. Bring the 2 down. Minus 6x. Subtract 1 from the power. And this is a 1 power. Bring it down. Subtract 1 from the power. The x is gone. So there we go. So we want the second derivative equal to 0 because those are our inflection points. So I set it equal to 0. Now, how do I solve that for x? Well, you notice you can factor out a minus, or just divide. Let's do that. Let's get it out of there. Who wants it? Let's get rid of it. Don't even need to factor. Just divide by minus 6. And so what do we got? X squared plus x minus 2 is 0, right? Because 0 over anything is 0. So that's nice. You can factor that. Remember how factoring works? We're thinking f, okay, try that again. F O I L, right? Front times front to make front. That's x times x. Last times last to make 2. 1 times 2. What's that sign in the middle always goes to the bigger. Plus 2 minus 1 makes plus 1 in the middle, and they multiply to be negative 2. So there we go. So then set each one equal to 0 separately, right? Because if two things are multiplying, two things are multiplying to be 0. Either one could be 0. You know the drill from here. Jump it over. Jump it over. Just changes signs. Plus 1. Negative. There's the two x values. Plus 1, negative 2. That's the two answers they got. So that's right here. And that's right here. Minus 2 and plus 1. Those are the two inflection points, the places where the second derivative is there. So I took the second derivative, first derivative, then second derivative, set it equal to 0 and solved. Found the two places where the second derivative is 0. That's where we have inflection points where it changes from concave down to concave up and then back to concave down. So that tells me the section that is concave up. So that is how we do that. Find those inflection points.